I got drawn in on sort of into the subject about what happens after the fire. I just want to share some experience with you.
I learn so much by talking to other people that I meet, and I make really long-standing connections.
Pouring water onto an EV in thermal runaway is like pouring water onto the roof of your house when your kitchen's on fire. Thank you, gentlemen.
Thank you. Good afternoon, everybody. Conor Logan. I've worked in smoke control for, well, coming up for 38 years. There isn't a smoke control system that I haven't either designed or implemented somewhere in the UK or around the world. So it was obviously quite important for us to get involved in Treble 9-1. There's a lot that smoke control can do to aid people evacuating buildings in the event of a fire. Quite a mammoth task. It's a standard that will never be perfect, and people will always have an opinion on how to make it better. But fire safety in the design, management and use of residential buildings, a code of practice, it's so important that obviously what we've talked about with Elspeth and Ben is the built environment and how people manage existing buildings, but this is how buildings are being built, and hopefully, having listened to some of the presentations this morning, we'll see that things are actually improving in the right direction. So as buildings are getting taller, and so much taller, particularly when you look out the windows here, making sure that people can evacuate safely or are safe within the buildings is of utmost importance. So considerations and challenges for the committee start with obviously the changes to legislation that we've had since the last variation of the standard. Obviously, we have the Building Safety Act bringing in sprinklers over 10 metres, single-stair residential buildings up to 18 metres only. The London plan with evacuation lists we've heard a lot about already. Changes to approved document B didn't go as far as saying we need evacuation lifts, but if you have one, then it should be afforded the same protection as a stair. Very sage advice, I guess, but no real content to it. So now we've got the Treble 9-1 update, which has considered both the Phase 1 and Phase 2 reports, the Smoke Control Association information on maintenance, which is coming out very soon. They put some guidance out on automatic opening vents and also on control systems for smoke control systems. And you'll guess, because of my background, that this is going to be a little bit of a smoke control orientated presentation, but I will try and cover the majority of the content. So the timeline of the standard went out for initial drafting in 2020 based on comments that had been received over the previous years on the standard. In August 2021, that drafting was complete and it went out for public comment. Just a couple of months later, the comment closed with nearly 19,000 comments. So a review process, a committee was set up to review those comments and either action them or justify why they wouldn't be actioned. And that ended in 50 days of meetings, both editorial and technical meetings, to resolve all those comments. Not all were taken on board, some rejected, some weren't. But obviously, Michael Gove had already said that a second staircase would be required to HRBs greater than 18 metres. So from Paul's presentation this morning, that is within the standard. 18 metres is the limit, the cut-off limit that NFCC wanted, that REBA wanted for residential buildings. I've got to admire Russ's clairvoyance here, because it was back in April when he asked me to come and speak at this event, not knowing then that it had been published last Thursday. So it's very opportune to be speaking at this particular time. And handily for me, at the beginning of the standard, I'm sorry about the small print, it does actually give us a list of some of the main changes. And while it's a very brief list, there is the highlights would be the scope's been expanded to cover residential care homes. Obviously, there was a lot of vague guidance for residential care homes, so that's kind of been distilled out. So there's an absolute new dedicated section for residential care, and some definitions to residential care as well. Some of the standards, I'm sort of jumping around a little bit with them, is leading towards the demise of the BS 476 standards. While there are still references to them in the standard, they are kind of being phased out. So that covers the reaction to fire classifications for load-bearing elements as well. There's clarification on the maximum building height covered by the standard. It is 100 metres, the maximum building the height it will cover. There are some additional guidances within there for buildings over 50 metres. But once you go over 100 metres, it goes down the fire-engineered QDR type process. The big one, obviously, an additional staircase for buildings over 18 metres, in line with Michael Gove's statement. And I guess easier to say what's not in here, and the one thing that's not in this standard is water mist. There was no agreement on how water mist could be designed in residential buildings without a test report that covered every single application, and so it was decided that we could not be recommending water mist within the standard. One of the big changes, I think, really is the updating recommendations for smoke control, and the introduction of recommendations for evacuation lifts, which is, again, is something that we're hearing a lot, both today but probably yesterday as well. So there are some more clarity within there as to evacuation lifts, how to plan for them and how to design for them. Basically, if you need a lift, or if a lift is provided to get into a building, then a lift should be provided to get out to the building. So it's level access for everybody. And the other main change there really was the update of references to power supplies. Under the old version of 991, there was not a requirement to have a standby power supply. Well, sorry, there was a requirement for a standby power supply, but there were get-out clauses if you didn't think it was practical. Now there isn't a get-out clause for not providing a secondary power supply, be that from an alternative substation or from a standby generator. Bit on product certification and some general updates. I mean, obviously it's quite a complex standard and it's really difficult to get all the details out of it in half an hour. So forgive me if I have jumped to the areas that I'm more familiar with, shall we say. So dealing with means of escape, some areas haven't changed. Travel distances are pretty much the same, up to 11 metres, single stair, 4.5 metre travel distance with an automatic opening vent at the head of the stair or on every landing as we had before. From 11 to 18 metres, then again, single stair is permitted with a travel distance of 7.5 metres, but obviously with most buildings being sprinkled. I'm sorry, some of the formatting seems to have gone astray in my presentation. So travel distances with sprinklers are 15 metres. One of the significant changes is that travel distance is measured not from the apartment door to the lobby, but from the apartment door to the stair, which is a big change from the old standard, because we found there was a lot of people trying to game the system by putting a tiny little lobby outside the apartment or a tiny little, a great big lobby outside the staircase. So that we're getting more and more travel that was kind of cheating, really, in terms of the intent of the limit of travel distance. So now that travel distance is measured from the apartment to the stair door. So I'm just trying to look through my slide and work out exactly where I am with it now, because unfortunately, the formatting has gone a bit skew with. So in our 11 to 18 metre range, we can have an AOV to the head of the stair. We need smoke ventilation to the corridor, which can be AOVs on an outside wall. AOVs, I mean automatic opening vents. It can be a natural shaft within the corridor with dampers on every level, or a mechanical smoke vent system, or a pressure differential system. Once we go over 18 metres, Obviously, now we're into the range of multiple stairs, and the same requirements apply. We're no longer permitted a single stair, but 15-metre travel distances and the same ventilation requirements. What you possibly can't see at the bottom is that over 30 metres, over 18 metres, the automatic opening vent to the corridor has now come out. So that's not an option. If a smoke control system is designed to keep the staircase clear of smoke, is to provide an ability to vent smoke out of the building, there was no evidence to suggest that taller buildings where wind pressures may be more prevalent, that AOVs provide a sufficient level of performance to assist escape. So natural smoke shafts, mechanical systems or pressure differential over 18 metres, and then over 30 metres, again, the natural shafts have been taken out. It's only mechanical or pressure differential systems over 30 metres. And a change to the requirements for automatic opening vents is that we've gone from having this concept of minimum free area that appeared both in approved document B and the old standard, which was very vague calculation of what we thought the area of the ventilator might be, to a defined classification of the aerodynamic free area, which you establish by putting your product on a wind tunnel and measuring its performance. And that's part of the classification of the product that would be of a certified product. And one of the drivers for this was to stop people taking a chain drive, sticking it on a window and calling that an automatic opening vent. It's not, and we'll cover that. The old standard said that area, or area 1 on that diagram, would be the minimum free area. So if you wanted 1.5 square metres minimum free area, you needed a 1.5 square metre wide vent that opened a metre. That led to a whole load of issues with, as I say, people putting chain drives on normal windows, which not only have limited performance, but also, I mean, the example you see there's no safety stays, so if the chain drive becomes disconnected, it could fall, shatter, and harm people at low level. There's no control on regards to finger trapping, not always a problem, but obviously there's a real quality issue. And when you see some of the actuators fixed to PVC surrounds or timber frames, the ability of these products to perform, I call them products, the ability of these to perform over a long period of time is quite limited. So that the aim was to get away from, I don't want to use the phrase Heath Robinson, but on-site constructed ventilators to proper certified product was the driver here. So we didn't have these great big sheets of glass hanging by a couple of tech screws. So a smoke control ventilator is CE marked to a standard, and that aerodynamic free area is part of the declaration of performance for that product. The components are tested together for reliability, robustness, resistance to heat, and if they're on the roof, to be able to throw off snow and to operate under wind. So it's quite a key change to move away from, as I say, chain drives and windows. So where do we use these? Obviously, this is the corridor. We've got a staircase at the end of the corridor. A furthest apartment to the staircase, assuming it's over 11 metres and sprinklered, will be 15 metres. The shaded area is where the smoke ventilation is provided, and as I say, the travel distance is to the stair door, not to the lobby. Couple of points on section 7, which covers lifts and evacuation lifts. Buildings that are provided with passenger lift access to an upper or lower level should also be provided with a means of using lifts for escape. As I say, you need a lift to get in, you've got a lift to get out. And then at least one evacuation lift should be provided for each escape stairway. So you've got 2 stairs, and you need 2 lifts. There is a possibility of putting that alongside firefighting lifts, which will becomes clear as you start to design buildings to the standard. A couple of other things to point there. For buildings with a story over 50 metres or more above ground level and designed with a stay-put strategy, every lift should be designed as a firefighter's lift, programmed to function as an evacuation lift until the lift is required by the firefighters. So there's some extra resilience there as well. It does obviously beg the question, how do you design an evacuation lift? And of course that doesn't quite exist yet. And the note 2 there, when it refers to BSEN 8176, which is the evacuation lift standard, which is being rushed through the CEng process as we speak, hopefully. Because it is very hard to get lift manufacturers to certify a lift that doesn't do what it was originally designed to do, which is ground in the event of a fire. When we look at the position of the lifts, there are a number of issues, because every lift should have an evacuation lift lobby or waiting space. I'm not sure the exact term we call it, but in each of these examples we can see different requirements. So in the top one, the lift is actually in the staircase and the waiting space is in the stair. In the second one, the lift is in the lobby. Again, the smoke control is in with the corridor lobby as well. In the top right one, we've got the two staircases side by side with a door in between. We've got two staircases, we've got two lifts, and we've got two waiting spaces. So again, normal smoke control requirements apply to that one. In the final one, they've taken out the door between the two lift lobbies. In that instance, it's requiring pressurization. So a pressure differential system will be provided when there's no separation between the two evacuation lifts. So what does that mean? So the evacuation lift lobbies should be, or the waiting spaces, should be offered the same protection as the staircase. So if it's below 11 metres, we're not really offering a great deal of protection from a smoke control point of view to the staircase. But, so there's no additional requirements for the evacuation lift lobby in that instance. When we go over 11 metres, the premise of the smoke control systems that we're designing is to protect the staircase from smoke ingress. So the add-on is that if you've got a system that protects the staircase, it's now got to protect the lift lobby as well. So that means we can no longer extract from that lobby. You've got to extract from the space beyond the lobby and provide either have inlet air coming into both the stair and the lobby, or pressurize the two. So I think what we need to understand really is how architects are going to start, which of these is their preferred option. And I think there's going to be a big question about net versus gross when these start to be introduced into new buildings, and which of these options is the most viable solution. Because at the moment, as writers of the standard, it's not clear to us how that will be taken on board. Because obviously, once all these are introduced into the building, the way to recover the additional cost, I guess, is to make the building higher. So things will eventually get a bit taller. So for smoke control, some big changes as well. It used to be in 991 and in 9999, I think, that if you were putting a smoke control system in and it was going to be a mechanical system, you had to design it to be at least as good as the equivalent natural system. So the process would be, you'd calculate how good a natural AOV or a natural shaft would perform, and then you would provide a mechanical system that would do the same thing. So if it didn't perform very well, the mechanical system could be just as bad, but it wouldn't be any worse. Now what we're saying is that mechanical smoke vent systems need to be designed to keep the staircase clear of smoke. It's not comparative anymore, it's definitive. So that really means more modelling, I guess, and demonstrating that the performance of the system achieves the conditions we're trying to achieve. And then, Paul, I'll refer to your presentation earlier with your smoke going into the staircase. We're designing these systems to keep that smoke out of the staircase. Okay? So if you change your animation, that'd be great. I mean, and obviously, when we look at Grenfell and the comment about the smoke control system not working, there's no evidence to suggest that the smoke control system didn't operate. it was never designed and would never have been designed for a fire of that severity. So there is some guidance on CFD, and there's a lot of small print here. I've put it in so you can refer to it in the handouts. I don't suggest that we go through it, but obviously when you're doing CFD analysis, it's making sure that it is of the right standard, it's done by reputable and competent people is the critical point there. So into the smoke control provisions, as I say, the requirements are very similar to previously in terms of automatic opening vents or natural shafts or mechanical shafts, but now we have these aerodynamic free areas that actually means you need to use a proper designed piece of equipment rather than just a window with a chain drive. And the other big change is that when you get to a basement level, if your basement is more than 10 meters deep, this got lost from both 999, I think, and treble 91 before, that a deep basement could be given the same protection as any other level. It used to be that a deep basement would have staircases protected by a pressure differential system, and so now that has been reintroduced. How it got lost from the last version of the standard is very difficult to tell, but it is now back in there, and because going into a deep hole in the ground with only a staircase to get back out again to fight a fire is quite a terrifying procedure. I wouldn't like to be there myself, so having the best possible protection to that staircase is essential. Just to go over the other things that we kind of mentioned, AOVs up to 18 meters only, natural shafts up to 30 meters only. After that, it's either mechanical or pressure differential. As we said before, power supplies, secondary power source now should be a generator or an independent feed or a UPS. There is no option to say, well, it was too difficult, so we don't do it. It's got to be there. Quite a bit on maintenance now. It used to be that treble 91 used to refer to other standards for maintenance. It's now got its own requirements in there. And obviously smoke control, being a life safety system, testing and maintenance is a requirement under the fire safety order. So what we recommend as a business is that, and as an association really I suppose, is that there should be daily inspections of the smoke control system, as you would with a fire alarm, just to make sure there's no faults, there's no flashing lights, there's no red lights on it, that it's ready to function. And every week, a test, and these can be done by the occupier, the responsible person, I guess, and then every quarter a full test of the system. So if you've got a high-rise residential building with multiple floors, you test so many floors a week to make sure that everyone over that cycle of three months is all those floors are tested. And then once a year, a full maintenance inspection and performance test by a competent service provider, and obviously a 5-year electrical inspection as well. But the competent service provider, obviously making sure that not only is the system operational, but as a sample of the cause and effect is carried out to make sure that the right system works on the right level, and it's tested from the fire alarm as well. There's a big scope gap in maintenance and testing, that people test their own things and they demonstrate it's working by pulling out the links to the fire alarm. That doesn't really prove that the cause and effect from the fire alarm is giving the right signal. The only way to really prove it is to go back to the detector, smoke the detector, and let the fire alarm go off. Like obviously, when you've got an occupied building, particularly a residential building, that's going to be a very difficult thing, because all sorts of things might happen, like lifts grounding, gas being shut off. Can't think of any more off the top of my head, but peaks being initiated, perhaps, depending on the type of building. But it's the only way you can truly show that the system is going to work the way it's intended. So it's quite an important aspect. As I say, residential care homes, there is a whole section 56, on residential care homes. And one of the things that is in there, it deals with progressive evacuation, but also it introduces smoke evacuation, including evacuation lists for residential care homes. They've been quite neglected from what I can tell in sitting in this committee. I won't dwell on it, but there is a simplification of the design decision tree for atria, particularly if your evacuation is through the atria or along the balconies of the atria, then that leads you to a more onerous solution. Smoke shafts, big topic at the moment. Ever since the British Gypsum, I think it was, withdrew their classification for shaft wall for the design of smoke shafts, and now there is a big controversy going on as to how smoke shafts could be constructed. I mean, everyone thought shaft wall, the clue was in the name, it could be used for smoke shafts. British Gypsum have turned around and said, well, no, we've never actually tested it at high pressure, so we don't really think it should be used as for smoke shafts. For those that are not familiar, a normal gypsum or plasterboard wall would be a couple of sheets of plasterboard around a steel section, which is symmetrical. It's the same in both directions, and it will generally withstand a reasonable amount of pressure and will be fire rated. A rigid construction would be concrete or block wall, but a shaft wall is a form of gypsum board that can be installed from one side only. So it's really handy for contractors to build, particularly shafts using this, but it's not a standard wall construction because it's asymmetric. So you have to test every single variant of it to prove that it offers what you want. But one of the tests that have never been carried out is pressure testing. I won't dwell on it too much, but the guidance really is from the Smoke Control Association, and it seems to be coming from the ASFP now, and the finishes and interiors sector, is that your shafts should now be provided by either smoke control duct that is I've tested in both directions, or from concrete. So that's another shaft within a shaft, and there's a whole load of questions about how you detail that in terms of what's required. And some various things that have crept into Treble 9.1 is some classifications for smoke control dampers. There's a lot of detail in there compared with some of the other areas of the standard, but again, making sure that the right product is used in the right application. So, starting to recap, when we've got our small buildings under 11 metres, our smoke control requirements are single stair, head of stair ventilator. Once we go over 11 metres, we now introduce sprinkler protection. Once we go over 18 metres, we're up to 2 stairs, and over 18 metres, we're losing these automatic opening vents. When we go over 30 metres, obviously we've got the wet riser in there now as well, but also we're losing the natural shafts. And then anything beyond that is either mechanical ventilation and pressure differential systems. And as with all things, I always like to finish this slide. The design of the system, the building, whatever you're involved with, obviously there's standards and guidance for that. That gets you across the first line, that gets you across Gateway 2. Then you get into the installation, and we've talked a little bit. We had conference bingo this morning with third-party certification, but installation of the system should cover some third-party certification. Then the equipment that you use has got to be fit for purpose. It's got to be the right product for the right application. And the Construction Products Regulation, not just the EU version, but the UK version, which is virtually the same, means that these products should be tested to a recognised standard and should be certified to that standard. Commissioning, again, that can be part of a third-party certification scheme, but it's so important that the commissioning is done in the right way and is total. But that's all well and good. You've got a fully installed system ready to go, and Gateway 3 is what is supposed to confirm that. But once the building's handed over and delivered to the owner-occupier, the maintenance comes into it, and it's so important that the maintenance is carried out, recorded, and done in a professional manner. So that all these buildings, where have they gone, are as safe today, or the day they're finished, as the day they, well, hopefully, they don't have a fire. So, thank you. Any questions?